So this is problem number 15 from page 303 in the textbook, and it's just like this problem out of my math lab you're asking about. And what we did, I drew a picture of this. So here's the circle with a radius of 3, centered at -2, 0, and then they want to know when does this line intersect the circle in the second quadrant. Now, this point here should be down in the third quadrant. My sketch is a little off. But this one certainly is in the second quadrant, so that's the point we want. So what we're going to do is we're going to write, you can certainly, Desmo will graph this for you. It'd be better to tackle this algebraically though. That's one of the requirements, or one of the essential objectives for the course, is to be able to solve nonlinear systems. So let's write the equation of the circle. Now you got to remember that the general form for the equation of a circle is you take the x minus the x coordinate of the center and then square it, and y minus the y coordinate of the center equals the radius squared. So I can write, let's see, so I've got x plus 2 squared, because it's a minus 2, plus y minus 0 squared, it'll just be y squared, and that equals the radius squared. The radius is 3, so the radius squared is 9. Now, I know that y is equal to 2x plus 5. That means even that y there, that place where they intersect, will have the same y coordinate. It also has the same x coordinate. So what we're going to do is we're going to replace y in our equation of the circle with a y for that line, and then we're just going to solve that resulting equation. So x plus 2 squared, which we'll have to expand out, and then 2x plus 5 is y, and that equals 9. And now what we're going to do is we're going to expand these out, and I won't make you watch me do those. So I expanded out this polynomial. Now what you got to remember, you got to FOIL. You got a binomial squared, so that means you got to FOIL it. You're not just going to write x squared plus 4. You got to write x plus 2 twice and FOIL. And then I did the same thing with the 2x plus 5. Then I combined like terms. And then because this is a quadratic equation, I set it equal to 0. And then this doesn't factor, so I use quadratic formula. Honestly, I used a quadratic formula solver. I didn't do this by hand, and I encourage you to do that. So here's the two solutions to this equation. Now if I'm looking at this, my graph, I can tell that this is probably the one that I'm going to want, and this one will be down in the third quadrant. Now what I should do is I should go back and evaluate. I could either use either equation, though I think this is the easier one to use. I'm going to replace that value in for x, find out what y is. The same thing here. In fact, I can see right now, if I plug in -3, substitute in -3, I'm going to get -6 plus 5 is -1, so that puts that point down in the third quadrant. So we know that one's out. So that's going to be the x value, and then replace x into that equation. That'll tell you your y value, the y value for the coordinate. So that's how the coordinate in the second quadrant. So that's how you solve this kind of equation. Hope that helps.